Alright, so guys, today we're talking about these things called radians. And then, well, I'll just try to tell you what a radian is up front. A radian is just another way to measure angles. Kind of like if you wanted to measure something with a ruler, you could measure it with inches or centimeters, right? Whatever you choose. Well, you can measure angles with radians or degrees. And so we're going to talk about what a radian is today. And then anytime you have two ways to measure something, you need to be able to convert from one to the other. So we'll be learning how to convert today from one to the other. And that's pretty much the gist of our objective today. So I don't want you guys to write this, but I would like you guys just to kind of mentally participate with me for a minute. So this is a circle. And then this is a center of the circle. And when you draw a line from the center to the side, what do we call that? That's called a radius. Now, if I were to imagine this radius to be kind of like a string, just like a string that I could actually physically pick up and bend however I wanted to, and let's just say I chose to wrap it around my circle, would you guys say it would go about that far? Yeah. Okay. Is that makes too much, too little? What do you think? Too much? Okay, we'll back it up a little bit then. How about like here? Is that more reasonable? Okay. So how many degrees would you say that is? Now let me show you what I mean. 65, 70, and we're estimating here somewhere between 60 and 45, right? Okay. So there it is. This is what we call a radian. A radian is the amount of angle it takes to capture one radius length on your circle. That's what a radian is. Okay? And it's approximately, as you guys can see, somewhere between 45, 60. We might get a real conversion in a minute. I can tell you, matter of fact, what it is exactly in a second. Let me figure it out real quick and I'll tell you. It is 57.29 degrees. So you're pretty close to 60, in between 45 and 60. So there you go. All right. Now here's another question. I'll let you guys think about it for a second. I'm going to pause the video. So before I pause it, the question is, how many radiuses will fit around this circle? Or matter of fact, you know what? Let me give you something a little bit that you'll understand a little better. How many radiuses would I need to put on there in order to get to halfway around the circle? So about 3, right? Does that make sense? I mean, so if that green line there represents one radius, if I were to throw another one on, it would probably get me that far. And if I put another one on, it would probably get me that far. But it looks like it's not quite there. But it's about 3. Now I'm going to tell you guys what it actually is. It's pi. This is where the number pi actually comes from. Pi is basically how many radiuses will fit in half of a circle. Are you guys familiar with the formula for the area? I mean, not the area, but the circumference of a circle. What is it? Circumference equals 2 pi r. In other words, the total circumference of your circle, the total distance all the way around, is 2 times pi radiuses. If 1 pi makes half your circle, then 2 pi's make a whole circle. Okay? So 2 pi radiuses will make your circumference. And so pi is a special number. It comes naturally out of the mathematics of circles. It's just there. It's what makes circles what they are. And so since we're dealing with circles, we're going to be learning a new way to measure circles. And in fact, it's a better way. We like degrees in math because degrees make sense to you guys when you're first learning things. Why are there 360 degrees? Well, I've heard a few different theories. One theory is because in a year there's about 360 days, and that's how long it takes for the Earth to go around the sun. So they thought, okay, we'll kind of keep that idea. But here's another one I've heard. 360 is an extremely divisible number. You could divide 360 by a lot of things. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 15. It can be divided by so many numbers perfectly. So it's a really nice number to use. But here's the thing. 360 is a man-made number. Somebody just thought, we'll just make it 360. We'll break the circle up into 360 pieces, and that's it. But that's random. But this is different. A radius speaks the language of circles itself. It's actually part of how circles even work. So radians are the natural language of how you really measure circles. Okay, and so for that reason we're learning it, but also because if you guys end up going to calculus, they don't do degrees. Degrees are gone in calculus. We only do radians. Okay, and so you usually end up with much cleaner answers when you work with radians. But the problem is radians are a little bit ugly. You guys will see why today. Here's why. They're fractions, and we don't like fractions. But they actually work beautifully when you're dealing with circles in calculus. So that's what we work with. So that's what a radian is. It's just another way to measure a circle, but it's the natural way to measure a circle. It's by how many radiuses there are in that circle. And so let's go ahead and write down the definition then of a radian for our notes. What is a radian? Okay. First of all, it's a way to measure the angles of a circle. It's a way to measure the angles of a circle. Second, 1 radian equals 1 radius length on the circumference. One radian is 1 radius length on the circumference, and we saw that that's about 57 degrees. And part of our goal today is going to be how to convert that. How did I even get that answer? So I'll share that with you guys in a minute. Okay, we'll start talking about the conversion factor. Converting with radians and degrees. So here we go. For a circle, if we're talking about degrees, what is half of a circle in degrees? 180, right? Now, when you're talking about radians, what is half of a circle? It's pi. Okay? So I'm going to, now that I've shared that with you guys, here's what I want you to have locked in your mind. For every 180 degrees, that's pi radians. Or for every pi radians, that's 180 degrees. Okay? Now we could get kind of weird about it and say for every 1 radian, that's 57.29 degrees, but that's a weird conversion factor. So we're going to work with nice clean numbers, 180 and pi. All right, now I'm gonna take a sidestep here for a second. You don't need to write this, but I'm gonna take you guys back to one of your favorite classes, chemistry. I know, stop the shouting of joy. But here's how it works. You guys remember converting. Now I'm not gonna do like the hardcore chemistry. Matter of fact, what I'm gonna do is really just basic math. But they do this stuff like this in chemistry. Like in chemistry, they say, okay, we have 500 milligrams and you want to convert that into grams. So here's how they teach you how to do that, right? First of all, I want to cancel milligrams out. So I'm going to multiply this by something, and what's going to go on the bottom? Milligrams. And let's say that I want grams. So I'm going to put grams in the top. So here's what we do. We ask ourselves, what's the conversion factor? So for every 1 milligram, how many milligrams is that? I think it's 1,000. I could be wrong. I think it's 1,000. So now these cancel, right? And we're left with 500 grams over 1,000. No, grams. 500 grams over 1,000, which reduces to 0.5. Cool?
5 grams.
So you don't need to write this. This is just an example, but there you guys go.
Too bad I
Erase it.
No.
Okay. So anyway, that's it. So now, but let's reverse it. Let's say I had 500 grams, and I wanted to convert that to milligrams. Now what goes on the bottom? Grams, and milligrams go on the top, and 1 gram is 1,000. The G's cancel. 500 times 1,000 is 500,000. So you guys see how that works? So you have to think about, what do I want to get rid of? That goes in the bottom. What do I want to have? That goes in the top. And then you got to have your conversion factor, which is 1 to 1,000. Okay? That's, I forget, dimensional analysis, I think is what they call it in chemistry. No? Stoichiometry, maybe? I forget. I can't. You did good in chemistry.
This looks super familiar in chemistry.
Yeah. And they do that all the time. Now, the ones they do is like, they're like 10 steps long. But yeah, this is only one. So yeah, it's pretty crazy. But we're going to do the same thing here, you guys. So let's back up for a second. What I've given you on this slide is your conversion factor. Instead of 1 to 1,000, when we're talking about grams and milligrams, it's 180 to pi. That's your conversion factor. So let's go ahead and I'm going to change slides for this next note, but you guys can just put it right underneath. So if we're going to convert degrees to radians, if you guys want to convert degrees to radians, I want to change degrees into radians. What do I want to cancel out? Degrees. I want to cancel out degrees so it goes on the bottom. Yeah. And what do I want to get out of this process? Radians. So radians go on the top. So what you want goes on top. What you want to cancel goes on bottom. Now what's the conversion factor? Pi and 180. So if you want to convert degrees to radians, you will multiply by this. You don't, and by the way, when we do the math today, I'm not going to write the words radians. Want to take it outside? All right.
Really, you messed up.
A little bit. I've been known to do that. Okay, so there's our conversion factors. So if you want to convert degrees to radians, you multiply by pi over 180. If you want to convert radians to degrees, you multiply 180 by pi. Let's go ahead and do an example here. Example 1. Huh? You didn't get the equations? I can bring it back if you like.
It's fine. Still have Ricardo.
Okay, let's do 30 degrees real quick. I want to convert 30 degrees into radians. That's my goal. That would be nice. Maybe one day. Okay, here we go. So let's do this. So I don't want degrees, right? So I'm going to multiply this by something, and I want to cancel the degrees out, right? So I want degrees on the bottom, and I want radians on the top. So what number am I going to put on the bottom? Okay. Now, you're going to think of this as over 1, right? We're going to multiply straight across. So what you end up with is this. Now, you could get get out a calculator, change this all into decimals and stuff. But just so you guys know, they will not write it like that. They're always going to leave it in terms of pi and reduced. So we're just going to reduce the fraction and leave the pi there. That's how they write the answer. So if I reduce this, what goes into 30 and 180? 30 actually does go into 180. But a lot of times you guys won't catch it. And just so you guys know, by the way, when you're doing these, they're pretty big numbers. So just so you know, every time you do this, if it can be reduced, then the numbers will always be able to be divided by 15. Because every number on your unit circle can be reduced by 15. Okay? But if I'm asking you guys to convert an angle that's not on the unit circle, like a weird one, like 57 degrees, that's not true anymore. But if we're converting angles on the unit circle, you can reduce by 15. But anyway, you could reduce by 6, you could reduce by 15, there's a lot of things you could reduce by. What I would do, the final answer, you're right. So if we divide the top by 30, what do I get on top? 1 pi. And if I divide the bottom by 30, what do I get? There you go. So on our unit circles, the 30-degree mark is, we're going to have pi over 6 as a radian in that spot. So pi over 6 radians is 30 degrees. Now, I'm going to tell you what that is just to make it make a little more sense. Pi divided by 6 is 0.5. So basically, it's about half of a radian. Half of a radius length is what 30 degrees would be. All right. But we will be writing our answers like this. So let's do another one real quick, but this time I'll let you guys do a little bit of the work. So number 2. Different color here. Number 2. So let's do a weird angle that's not on the unit circle this time.
99. 57. What do you think?
I'm going to go with 99. Let's do 99. Okay, so here we go. Kevin Tran. What am I going to multiply by? Yeah, easy. Yep, good. Now you can just memorize that, or you can remember, I don't want degrees, so degrees go on the bottom. I want radians, so radians go on top. Okay. Now we're going to multiply straight across, and now remember how I told you everything can be divided by 15? Yeah. That's only if the angles are on your unit circle. 99 is not one of our unit circle angles, so in this case you just got to be more creative. What goes into both of these? 90 doesn't go into 99. 9? Oh, I think I said 99. I'm sorry. Gosh. All right, so let's do that. How many times does 9 go into 99? And how many times does it go into 180? There you go. And does anything go into... Sometimes after you reduce once, you might have to keep going. But in this case, does anything go into 11 and 20 in common? So we're done. That's it. That's the answer. Now, I mean, if you want to find out how many radians that is, you have to do 11 times pi divided by 20. It's about 1.7 radians. Yeah, we never do, though. We always leave our answers like this in radians.
So, Bailey, if I gave you a decimal in the exam.
Yeah, it would be bad. Yeah, don't do that. Yeah, I won't give you credit for decimals.
I'm going to give you that.
All right, so here's what I want you guys to do. I want you guys to get out your unit circles right now. Get out your unit circles.
This was the only thing I was good at in chemistry because it followed the rules of math.
Are you filling in?
Chemistry, it followed math.
Yes. Yes.
Yeah, I know. And then they changed it. The year.
As you guys are looking at your unit circles right now, you have, we put all of the degrees in the little ovals, right? Okay, so I want you guys to do this with me right now. We had an oval here, and we put 30 degrees, right? But do you guys see how next to that oval there's a square, right? I think it's right here, right? We're going to put pi over 6 there because we did that one earlier. Remember how we said 30 degrees is pi over 6 radians? So we're going to convert our angles and put them in there, okay? Now, before we do, though, I'm not going to have everybody do everything. That'll take too long. So I'm going to break the class up. I'm going to have you guys here in this row. Would you guys do the first quadrant for me, please? And then you guys here, would you guys do the second quadrant? Would you guys do the third quadrant?
We have no choice in the matter.
Would you guys here please do the fourth quadrant? There's not very many people here, so I'm going to have you guys do the fourth quadrant also. And for you guys here, would you guys do all of these ones for me? The ones on the axes? Those four?
Yeah.
So you guys are going to convert your degrees. Okay? So take each of your degrees and convert them to radians and fill in your squares. And then I'll call on you guys. Well, we'll share out our answers at the end and we'll see what you guys got. Now, instead of calling on you guys just to save time, I'm going to tell you the answers, and you want to make sure these are right, okay? Because you need to have these correct on your paper. So, of course, this is 0 right here. Good. Now, for you guys that did all the axial angles for me, it could be 0, but if you think of it as 360, it's actually going to be 2 pi. Okay? So it's either 2 pi radians if you want to think of a full circle, or it's just 0 if you want to think of no circle, right? Now the next one, we already figured out that one together. That's pi over 6. The next one would be pi over 4. The next one would be pi over 3. The one on top here is pi over 2. And I'm just going to keep writing them, but if you can't read it, let me know. Are you serious? Okay. Oops. Now, guys, am I converting these really fast in my head? I'm not. What am I doing? I've memorized them. Guess what I want you to do?
Memorize it for Monday.
Oh, wait, no, it's actually pretty easy. Shut up.
See now, this one, hold on, shh, don't tell me. All right, 4, no, shh. Yes, 4 pi over 3.
He doesn't remember.
No, that's right.
He's not superior anymore.
We have become one.
Mutiny! Mutiny! There it is. So make corrections if you got something wrong, but there it is. Now, so you guys already know I am expecting you to memorize that. No, I didn't go through and calculate those really quick. I'm not a super calculator. I've memorized them. And I want you guys to be able to do that too. Got a question? This one? 4 pi over 3. All right, now, here's the thing. These are, in my opinion, the worst one to have to memorize. Okay? We're going to learn, there's another thing I'm going to ask you. There's 2 other things we have to memorize, but these are the worst ones because there's pretty much really no pattern at all. It's just random numbers. Okay? So, and now when we take our quiz on this on Monday, because I am going to quiz you guys on your radians on Monday, just like we did with degrees before, when we take our quiz, I'm not going to give you enough time to sit there and convert these all. We don't have enough class time for that. I want you to memorize them. I want you to be able to know the answers and put them up there. All right. So, we're looking at about 3 to 5 minutes for your quiz, just to write all those on there.
5.
Sure, why not? It took me about a minute, so I think 5 is good to expect from you guys.
Makes sense.
Hey.
What is that
Concur.
figure next to 5 and 11?
Say that again?
Quadrant 4, what's that one?
Yeah, that one.
7 pi over 4. And by the way, anytime you guys lose a unit circle or something, they're already on Google, so just type in unit circle. They're there. You can just print one out. But I like having you guys fill one in as we go. You guys should also probably fill these degrees in on the back side of your paper, starting with 0 all the way down. So if you want to do that, I'll pause for a minute. Go ahead and fill in all those down the side. So start with 0, pi over 6, pi over 4, pi over 3, so on. there's not much that's helpful in memorizing other than just taking the painstaking time to do it. So first of all, here's some cool patterns to take note of. First of all, we have this one. I don't think you even need to memorize this because just common, like it from what we talked about, just makes sense. This is 2 pi and this is pi, right? We already know we drilled that into your mind already. You guys already know half a circle's pi. So obviously a full circle is 2 pi, right? That's just kind of easy to remember. But let's talk about some other patterns. Now, what I'm going to be focusing on for the most part is the denominators. But first, let's focus on the middle ones here. Check these out here. This guy, and this guy. These are all the middle angles of the quadrant. Oh, wrong one. These are all the middle angles of each quadrant. They all have the same denominator. What is it? 4. And here, these are the easiest ones to memorize because the numerators have a very nice pattern. They go up by odds. 1 pi, 3 pi, 5 pi, 7 pi. That one's nice to memorize. Now, unfortunately, there's not much I can do for the other ones other than tell you that there are some common denominator things. So look at all these guys here. All the ones that have pi over 6, they have something in common. That's true. They are right across. That's a very good observation. So you notice the symmetry there?
They're all odds.
Whether you're going this way or vertically, they're all the same, right? But here's how I think of it. The ones that have 6s in the bottom, they are closer to the x-axis. Whereas all of the ones that have a 3 in the denominator, once again, like Kaylin said, they're directly across from each other symmetrically. But they're also closer to the y-axis. So denominator of 3 are the ones that are closer to the y-axis. Denominators of 6 are the ones closest to the x-axis. And then we have the middle angles, which all have denominators of 4, and they go up by odds in the numerator. Here's another thing you can notice for a pattern. Like Kaylin said, I think this could be helpful. I'm going to come back to what he said in a second. So check this out. This is 6, right? 4, 3, 2. They're going down every time. Now, they're not going down by the same amount every time. Like from here to here is a distance of 2 spaces apart, 4 and 6, but the rest go down by 1s. So when you're doing your unit circle on whatever it is, Monday, here's how you guys can start. You can be like this. Okay, I know this is 2 pi. I know this is 1 pi. Okay, so it's going to have 3 here. I know it's going to be 6, 4, 3, 2. Those are my denominators. And then using what Kaylin said, you can use symmetry. You can be like, okay, so right across from that, this is a pi over 6. Well, you could put pi if you want to. We'll get to that. And then pi over 4, right across from that. Pi over 3, right across from that. So once you have that first quadrant, you can copy it. The issue is going to be the numerators, right? So pi over 6, pi over 6, pi over 6. Just using that symmetry. Pi over 4, pi over 4, pi over 3, pi over 3. Then you got to do the numerators. Now, for the middle ones, it's easy. For the middle ones, they go up by odds. 1, 3, 5, 7.
11.
And unfortunately, for the others, I really just don't have much advice for you other than you just got to sit down and drill yourself.
I didn't even look at my paper. I was do that one.
Oh, I see what you're saying, yeah. So feel free to find patterns yourself, but that's what I use.
Bailey, you didn't have to tell us this. Like, us three were already figuring out patterns and starting memorizing.
I appreciate that. Now, guys, I'm going to even put it on your Google Classroom night to study. And what do I mean by study? I mean, you know, you're going to find your mom or dad or brother or sister, and you're going to say, all right, quiz me. And you're just going to drill it.
So what you're saying is
tedious thing.
befriend index cards.
You can do flashcards if you want, but you actually have to sit down and try to commit it to memory, right? If you just come in here and try to wing it, you're gonna get a bad grade. So be prepared to study for it. All right. Moving on. So we are now on example 2. Convert 2 degrees. So guys, this is a little bit different. we're going to be converting to degrees instead of radians. Why would you ever want to do that? Well, I taught you guys how to convert degrees to radians so you can figure out your unit circle. So let's just say you're doing your memory work, you do a really good job, you have some extra time. I was kind of unsure of this one. If you have time, go ahead and try to convert it and make sure you're right? That's what that's for. But why would you ever want to convert a radian back to degrees? Well, because quite honestly, that's what just makes more sense to our brains right now, right? I mean, if I asked you guys where's 120 at, you'd be like, oh, okay, I see that. That makes sense. But if I said to you, where's 2 pi over 3, you're going to be like, I don't know what that means. So we already think in degrees. So sometimes if you get stuck and I give you a radian and you want to figure out where that's at in the unit circle, it's kind of nice to be able to turn it into a degree so you can have an idea of where it's actually located. So here we go. Let's do that. So I'm going to give you guys a radian. Let's say number 1 here. Let's try pi. Let's say 2 pi over 3. Let's do that. Now you guys could totally cheat. Just look at your unit circle. Right? Maybe. I can't count on that, but maybe. Now, how do we do it though? So let's pretend we don't have our unit circle in front of us, and let's do this. So we want to multiply by something. I want to get rid of the
Pi.
which is radians, right? So I want to get rid of the radians. So I put that on the bottom, and what goes on top? 180. I want to keep, so I want degrees. That's my conversion factor, right? So now this is going to be a little bit different, okay? For this one, degrees are okay. Decimals are okay. So you guys were asking, can it be decimals with radians? The answer is no. Leave misfractions because that's how we do radians. With degrees, decimals are okay. You can write those as decimals. So on this one, calculators are kind of our friend here. So first of all, let's cross that off, right? And next, let's just multiply straight across. And if you need a calculator, go ahead. But let's go ahead and do the division. What's 360 divided by 3? There you go. And now you can cheat if you want. Look at your unit circle. Do you see how the 120 is in the same spot as the 2 pi over 3? It's the same spot, just in different measurements. All right. Now I'm going to give you one that's not on the unit circle. Ready? Yeah, you are. 5 pi over 7. Right? I want to convert that into degrees. So, Anaya, what am I going to multiply by? Good. Ishmael, what do I do first before I multiply? Eliminate the pi thing. And then after that, we can go ahead and just do the math. So on your calculators, if you want to. Oh, you already did it? I don't know. I'm just going to show my work. That's 900?
Yeah. Over 7.
Over 7, which is? 1. Is exactly 128?
0.7.
Good enough. Okay, so let's put at least some numbers after the decimal so we know it's not just a whole number. But there you guys go. So now you guys know that weird. If I asked you, where's 5 pi over 7 at on your circle, you'd be like, I don't know. Because it's not one of our special angles on the circle. But by converting it, you guys can see, oh, it's pretty much right after the y-axis somewhere. Right? So now you kind of see. All right, so I'm going to, I want to give you guys one more to let you do it completely on your own, and that'll be the end of our lesson. Yeah, so here we go. Let's do 8 pi over 11. Go ahead and convert that into degrees for me, okay? Not what she's doing, but I just want to get the answer on there.